In this video, we are going to talk about the difference between static and non-static. So you may have noticed that when we first started off, every method that we wrote had the static modifier, like the main method has in Java. Um, and then as we started talking more about classes and objects, we stopped putting static we stopped putting static on the methods in those classes, in particular the classes that we use to represent, say, real world objects. Okay, and like the get set methods in those classes, we did not have static on there. So in this video, we are going to talk first about static fields, and we'll probably leave it at that for the moment, and then later on talk about how to reference static methods versus ones that are not static. All right, so first we're talking about fields. When you declare a field as static, so when you put static as one of the modifiers for a field, or remember a field are those data variables that go up at the top of the class. The big difference is that there is only one copy of that field in memory. It is shared by every object that you create from that class. Whereas if it's not marked as static, then each object has its own version in memory. Okay? And so if you have a piece of information that is shared by every object in the class, then you can mark it as static, and that way it will save some memory. Okay? All right, fields that are not marked static are called instance fields. I will probably say non-static most of the time, just because I think at the very beginning it's a little easier to realize exactly what I'm talking about. Uh, in Java, the instance fields, the ones that are not static, there's no static in front as a modifier, so no static in front of the name. Okay, so let's just take a look here. I've got a class called my class here. This is a regular field like we've been dealing with before, and here is a static field. Okay, so it has static as a modifier up there. All right, and so basically this field is going to be shared by all of the objects. In memory, there's only going to be one version of my static var. All of the objects will have access to it. Whereas with my var, right, it's non-static. That means that every object is going to have its own version of it. Okay. All right, so before I get into the next example, then let's run through this my var and just kind of see how this works. All right, so like I said, I have two fields, my var and my static var. They're both int fields. This one is non-static, right? Whereas this one is static. I have a constructor, okay? And that constructor has one parameter, the parameter for my var. And in line 8, it just sets the value of that field to whatever gets passed inside here. Okay. And now this next line, line 9, what I do is I add 1 to my static var. Okay. So this is going to be 0 to start off with, because int fields, right, in a class are going to be initialized to 0. So when I create that first object, this is going to be a 0. It's going to increase my static var to a 1. Okay. All right, and then this toString is just so we can print out and see the values of my var and my static var. Okay. All right, so over here I create 4 different my class objects, and this is in testmyvar.java. And you can see this one has a 1, this one has a 2, this one has a 3, and this one has a 4. Okay. So what's going to end up happening is that I'm going to get 4 different my class objects the value of these variables, right, is going to be uh, 1 in the first object, 2 in the second one, 3 in the third one, and 4 in the fourth one. Okay, so that's not a real mystery so far. The new thing, the new concept is related to this static variable here. Remember, I said that it's shared by each object in there. So let's just run this and we will see what the value is here. All right, and so you can see, just like I said, the value of my var for all of these objects is 1, 2, 3, and 4. But you can see that the value of my static var is 4 for each of these objects. Okay, so let's go through in detail and kind of see how that has happened. All right, so I'm going to be running through this in Canvas. So this is going to bounce in, and unfortunately, one of the things is, yes, there it is. Here, now we'll be able to trace the value of my static var right here, right, and hopefully see how that goes through. So I'm going to click through. We bounced over into the my class constructor. My var is 1, and so we're going to see that it's going to set that to 1. And right now, my static var has a value of 0, okay? And this statement is going to add 1 to it. So when I click the arrow, we're going to see that that turns to 1 right there. And you can see that that just happened. All right, so it bounces back to test my var. And now I have this first object that I created. So we can see it's there. Now, in Canvas, it will not show the static variables as far as I know. So we'll just have to remember, right, that right now the value of that static variable is 1. Okay, and I don't see any way to, oh, there, I can see what it is. Okay, that's great. All right, so you can see that my static var has a value of 1. All right, so now I'm going to click the curved arrow again. We're going to jump into my class and create a new my class object with this 2 value. So we're going to jump in, and now take a look. This is incredibly important right here. The value of my var is 0, right? It's non-static, so it just got initialized to 0. And we're going to see in the next line, the value of my var is 2. This my var is going to get set to 2. When I click this curved arrow right here, we're going to see that get set to 2. So this first my var object that we created, right, A, has a value of 1. This my class object, B, that we're creating, in the process of creating, is going to have a value of 2 in there. But notice that the value of my static var is 1. That is from the creation of this previous object. And because this value is shared, right, you're going to see that it's increased to 2 right here. Okay, not 1 like you may think, right? Because this value, this has already been created, this variable, static variable, and it's shared by every object, right? It already had a value of 1. And so this was increased to 2. So if I keep going here. And I should get my variable B over here. And you can see it has a value of my var 2. Now here is where the huge difference in static comes in. Remember, B, when in the process of creating this object B, we set my static var to 2, right? And so there's no question why it's a 2 in here, right, in B. But now if we look back at A, we can see that it's also 2 for this A class. And that's because A and B are really sharing my static var. You can see that the non-static one is different, right? But the static one is exactly the same. All right, let's keep going. Going to create a third object. It's going to set my var to 3, and then it's going to add 1 to my static var, right? So now the value of my static var is going to be 3 when I do this, okay? So in the process of creating object C, my static var was increased to 3, all right? And pretty soon I'll be able to take a look at that. So here you can see the object C, right? Now the thing is, it had a value of 3, no question. But now if I go back and look, my static var is 3 under A, and my static var is 3 under B. It changed these, even though we didn't directly alter the value in A or in B. Remember, this static variable, my static var, is shared. All right, and then one more time, when we jump in to create the fourth, right, we increase the value of my static var to 4. It jumps back here, and we create that fourth object. And again, we can see that the value for my var is 4. The value of my static var is 4, okay? And you can see it increased it for 4 here. Here it also says 4. Here it also says 4. So this my static var, like I keep saying, is static, and so therefore it is shared by A, B, C, and D, and every object that you create. In memory, there's only really one variable, and it's all shared. Whereas this non-static variable, my var, right, every object has its own different copy of that variable, okay? So that is an illustration of how a static field differs from a non-static or instance field. One of the uses of a static variable, just like we did here, is almost exactly what we did. You can use a static variable to keep track of how many objects were created. In this case, my class objects. We created 4 of them. Okay. All right. As a sort of a real world example, I mentioned this in a previous video. Imagine that we were all sitting in a classroom and having class, and somebody ran in, and without giving any context at all, they said, "What's that person's name?" But they didn't really point to anybody. They didn't single anybody out. All of us would really not know how to answer that question because we wouldn't know who they were referring to, right? Different people have different names, so the answer to their question depends on what person they're referring to, okay? The same thing, so that would be an example of something, an instance variable, or non-static. On the other hand, right, if that same person busted into the class and said, "Hey, what class is this?" we really wouldn't need any reference. It really doesn't matter who they asked. We don't need any particular details because that's something that every student in the class would share. It's CMPS 1301, right? So it doesn't really matter who they're referring to or anything like that. We could all answer the question. So because that's something that all of the students in the class share, something that they have in common, okay? And that would be an example of something that you would have in a static field. So what that would kind of look like in code would be like this. If you look at this variable right here, a student would have their own name, right? Every student has a different name potentially. So that's some variable that would not be static. It's not shared. It depends on what student you're talking about, okay? Whereas the class that we're in, CMPS 1301 or whatever you want to call it, that is common to all of the students in the class. So if I were writing a class that represented a student in our class, then I would make this variable class name static because it's something that all of the students have in common. In the other version of that, if you make this non-static, right, don't put static right here, then basically what it would look like when you started creating objects, it would look like this. Let's say I created 3 different student objects. Each student would have their name. So this student's name is Adnan, then this student is Baltazar, and then this student is Corvallis. So every student has a different name, but in every one of those student objects, you would have a variable, and that would take up some RAM memory, right? Some RAM to do that. You would have a class name in there as well. So you'd be saving that class name over and over again, and it's not really efficient. You don't really need to do that since it's the same for every one of these objects. On the other hand, when it's marked as static, it really kind of looks like this. There is some separate variable in there that has the class name. So, and then the students, when you create these student objects, they have their own names because, people have their own name, and it's different for different people, so it's going to be different for different objects. But then the class name is up here. So here, if you created 1,000 different student objects, there would still only be one place in memory where this static variable is stored. Okay, so that's the difference between static and non-static. There is also a difference between how you reference static fields and methods as opposed to instance fields or methods, the non-static ones. To reference a static field, you put the name of the class and then the name of the field that you want to reference. In particular, a lot of times static fields are used for constants, that is, pieces of data in your classes that will not change. Okay. So a prime example of that is in the math class, there is a field called pi, okay? And we don't need to save that for every different occurrence of the math class because pi is the same number no matter what, right? And so it only makes sense to make this as static. So if you want to reference a static field from outside of the class, right, you would put the name of the class and then a dot, and then the name of the field that you want to reference. Okay. This gives another reason why it's important to start class names with capital M's, or capital letters, not M's. That's because you can tell whether a field like this would be a static field or not. Okay. So here, because this is a capital letter, it's a dead giveaway if you follow the naming conventions that this is a static field. Okay. If you want to reference a non-static field, an instance field, it must be done with an object. Number one, you've got to create an object like this, and then you use the object name dot and then the name of the field. Okay, if you can do that. Sometimes if this is marked private, you couldn't do that. But that's not the point of this. The point is the difference between referencing, right, the name, typing a name for a static field versus an instance field. Okay, so for instance, non-static, it's an object. You must create an object, right, and then use the object to reference the field. All right, it's very similar with static methods. So in a static method, right, you do not have to create an object to use the method. All right, so and static methods can be called straight from the class. So if you think back at the very beginning of the class, right, when we first started writing these programs, every single method was static, right? And that's because we hadn't talked about classes and objects yet, right? And so that's why we didn't create objects until chapter 3, right? Chapter 3 was about the first time that we started creating objects, and we didn't even really say what that was because that was for scanner, right? I just said create a scanner object, and then you can use these methods inside, okay? We haven't really done it yet. Now, incidentally, that's also why the main method is static, right? It has to be static because that's where execution of the program starts. So you can't create an object before the program starts, right? And so the main method is always static, okay? All right, so remember with fields we said that if it's static, then you put the class name, right? And then the method call after that, after the dot. So An example of a static method call is math.square root 4. You put the class name, right? The class name is math, and then the dot, and then the name of the method that you want to call, and then any arguments that you want to give to the method. All right, so that's an example of a static method call. Again, the dead giveaway is that there's a capital letter right here. All right, so non-static methods, they're also called instance methods. And just like with fields, right, you must create an object to use an instance method. All right, so the first example that we ever encounter from that is with scanner. Okay, remember we were using scanner to get input from the user, and what we wanted to do was use this next line method that's in the scanner class. All right, and that would get the user input as a string. All right, and put that in that variable. So if you go look at the documentation, this next line method is not static. Okay, it's an instance method. So what that means is that in order to use it, you must create an object. That's what we were doing up here back in chapter 3, even though we didn't say why we were doing that. I just said create a scanner object, and it will read in what the user wrote. So the reason why we had to do this, right, why we had to create this scanner object in, is because next line is not a static method, so you must create an object in order to use that. And the dead giveaway that this is a non-static method, an instance method, is this lowercase I right here, all right, and the fact that we created an object. So, but even if you go just by the name, you can kind of tell whether or not it's a static method call or not. Okay. All right. And here are some rules for referencing static and instance methods. You might get some errors if you try to reference something that's wrong. You'll get this can't be referenced from a static context if you make some errors like this. Just a little bit more terminology. A member of a class is a field or a non-constructor method of the class. The rules for referencing those things is as follows. So if you have an instance method, that's a non-static method, it can refer to a static field in the same class. That's not a problem, right? Because of the fact that that static field is accessible to every class. It's shared by all of them, so there's no problem. An instance method can call a static method. Okay, again, the static method is basically shared by all of the classes, all of the objects in there, so that's not a problem. It is not necessary to create an object to use a static method. That's one of the main things that we talked about earlier, right? You would just put the class name and then a dot and then the name of the method that you want to call. And then an instance field, an instance method or field can only be used in the context of the object, right? You can't try to talk about that outside of an object. That is the situation where you have the person coming into the classroom and not making any reference to anybody and asking, hey, what's that person's name? Java, right, is not going to know how to do that. It depends on the object, and so it has to be, you have to create an object and then use that object to call the static method or reference the field. All right. And one last little bit of terminology: static members are sometimes called class members. So you'll hear class members or instance members and that sort of terminology. I'll generally try to keep it just as simple as I can. This is a fairly complicated thing to understand. Probably one of the more complicated things to understand in our class, in the first programming class. Okay, that's it for this video, and I will see you in the next one.